were. I told you guys that this up here is theta. Right, this makes a right angle here. And what we said was that n sub x is our centripetal force, and n sub x is n sine of theta, and the centripetal force is m v squared over r.
Yeah, this is what we said, or what?
Oh, so this is where we were, and then at this point I said, well, n is this guy here, and that was wrong. Okay? So the reason being is, if we say that the magnitude of n is equal to this component here, then that means that this object is allowed to accelerate down the ramp.
And it's not?
And it's not, because we're driving in a circle at this position on the ramp. Does that make sense?
Could you say that again? I didn't get it.
So, if n equals mg cosine theta, then f down the ramp does not equal 0. Okay? So if this normal force is exactly equal to this y component for the force due to gravity, then the force down the ramp is not 0, which means we're driving our car and we're sliding down the ramp at the same time. And that's not what we want to have happen in this case. Okay? We want the object to be stationary there.
So it's equal to mg.
Right? So in order for us to make sure that it's stationary, if we say that the only force in the x direction is in x, that provides our centripetal force. And then to make sure that this guy doesn't slide up or down, then ny equals mg. So this component here for the normal force equals mg.
Bless you.
And ny is n cosine of theta. Now if we solve for n, we get mg over cosine theta. So now we're going to substitute this in there. So we're going to have mg sine of theta over cosine of theta equals m v squared over r.
The mass is cancelled.
The mass is canceled, again, because we don't want to have to worry about the mass of our object as it's trying to complete the circle. And then if we solve for v, we get gr sine theta over cosine theta, square root that guy, that equals v. I'm sorry? And yeah, you can replace this with tangent.
Why are those freeways unmade?
Why are they?
Why are they?
Because again, this is assuming that we have very poor tires. Like the amount of friction for our tires does not matter in this case. As long as it's banked like this, we will complete the circle. Even if our tires are, we'll complete the turn. So long as we don't go faster than this. So this is where they would calculate that speed limit.
But what I'm saying is that like the velocity that you cannot reach, like you cannot pass on an embankment is higher than a velocity that you cannot pass on a regular slope.
Velocity. Say that again.
Okay, so like you're going on an embankment, right?
Yeah. So unbanked, flat.
Unbanked, you have to go less slow.
So that
you
was
have to go
this.
slower than you would have to go on an embanked road. On a banked road.
Wouldn't you go faster on a bank road?
But this was
On a bank road.
using friction. There was a mu in here.
Yeah. Oh, okay.
And this was just using the angle of the ramp itself.